Hello there, I am Dr CN Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. I want to welcome you very much to my channel once again. And today we are going to start a new series and we're going to look at set theory. In our first first lecture we're going to have on set theory, today we are going to look at set operations and notations using two sets. I would need to go through with you on certain notations you will need to get familiar with as you deal with set theory. Set theory is a branch of mathematics that has to do with counting and classification of items in groups. So we're going to look at scenarios from here where you have different values in different sets or members or elements, and how you can count them and place them in their right position. The beautiful thing about set is that you can only count an item once, and let's see how that can be done even though you have a particular item in several groups, and how you can reclassify them and place them and count them. That's the beauty of set theory. So follow me as we look at what we have illustrated on our workboard at this time, and please take your paper, take your pen, and write notes as much as you can. Thank you very much for joining me once again. Please do not forget to subscribe to this channel, and also like this video, and do me a great favor of placing a comment or two. I would really like to hear from you on the progress we're making and possible improvement that we need to make on this channel. You're very much welcome. So let's look at what we have on the board. Now, what we have on the board is set theory, operations and notations, but then we're looking at two sets. And I've illustrated it by saying that in sets, we represent set names by letters. U means universal sets, and we have a set A, we can represent anything, and set B can represent anything. Then we have members of a set are usually placed in braces like this. Members of a set are usually placed in braces, and the members of a set can be placed in a list or whatever. Now these are just like this number 1, 2 to 9 can be anything, but the universal set, which is like the population, is what you have as 1 to 9. Now set A is a subset of the universal set. Set A is part of the universal set, and set B is also part of the universal set. It's just like taking a sample from the population of a study, a sample from the population of the study. Now, the set operations refer to how we manipulate sets. In this case, when we talk about operations in mathematics, what we mean is doing our basic addition, subtraction, division, and multiplication. So in this case, we call these set operations, we call number one, we say union. Here we have union of set. Let me add of sets here. We have union of sets, union of sets. That's one operation. Here we have intersection of sets. Okay, so now when we talk about union of sets, we mean values in both sets that appear at least once. So it's a case of saying A or B. So A or B is union of sets. So in this case, if you can see what we have set A and set B, and we have listed all the members of set A or B. Whether they appear in A or B at least once, we will place them like they will list them out. At least they appear once. As you can see, we have 1, 2, 3, 4. Even though 4 are appearing twice, we count once. So we have 4. Then we have 5 appearing twice, but we'll count once. And then we have 7 and 9. So we have 9 here. So this, and when we talk about union of sets, look at the way it's been, the illustration of union. We have 1, 2, 3, 1, 2, 7, 4, 5, 3, and 9. And the union of set has to do with taking everybody in the sets. This is what we mean by union of set. So we're concentrating on the number of members of all and both sets in this case. And this is a Venn diagram. This is a Venn diagram having square or rectangle and circles that are interwoven. So this is how we represent union of sets. Union of set. All the members of the set are counted once. This is what we mean by union of sets. Now, the next one is the intersection of sets. Intersection of sets. This is how we write intersection A. Then we have the sign here and B. So, and A and B, we say it is A and B. A and B. In this case, A and B refers to the values or the members that appear in A and B. Not A or B, A and B. So that's the intersection. In this case, let's go back to what we have here. We have set A and set B. So let's look for members that appear in A and appear in B. In this case, we have 4 appearing in A and in B, and we have 5 appearing in A and in B. So in this case, we represented this how it's represented. So when we talk about intersection, what comes up here that is common, the common values or the common elements that are in both sets, and this is where we're concentrating when we talk about intersection of set, and this is how it's illustrated in set theory. Let's move to the next one. The next one is what we call the difference of sets. The difference of sets. In this case, we have A minus B, or we say A only. The values that are in A only, that are not in B. The values that are in A but not in B. So let's look at our illustration here. We have set A is 1, 2, 4, 5, 7. Now, since we have 4 and 5, appearing in B, we are going to exclude them. So that what will be left will be, now let me do this. Let me use this to cover what we have. If we cover this here, what are you going to be seeing in set A? You're going to see 1, 2, and 7. You see, when we cover this, and these are the intersection, these are what's similar here. When we cover this, we're going to be left with 1, 2, and 7. So whatever is similar, whatever is common in that set, you remove, and you're left with this and the 1, 2, and 7. And that's what we have here. So you have 1, 2, and 7. And the way we calculate is that we say number of A minus number of A intersection B. We already know that A intersection B, please follow me, A intersection B is 4 and 5. So what we do is to remove 4 and 5 from A, and we're left with 1, 2, and 7. And this is the way it's illustrated. A only are the numbers or the elements or the values that are in A only. These are illustrated in sets. So this is A only. So it is 1, 2, and 7. Let's go to the next one. This is now the reverse. We have B minus A, or we say B only. B only, just like A, is going to be the elements that are in B minus the intersection of A and B. In this case, please look up here. We have 4 and 5 as the intersection. So if we remove 4 and 5, what are you seeing? You are seeing only 3 and 9. So 3 and 9 make up the B only. So this is how it's illustrated. So we have 3 and 9 in our set B, and this we're concentrating on B only. This is A only, and this is B only. Are you following? Thank you. I know you're following. This B only. So this number of B minus number of A intersection B. Some students may say that, why don't we say number of B intersection A? It's still the same thing, but we'll leave it as number of A intersection B. The last but not the least illustration is where we have the complements of A union B. What does that mean? A union B, we already know A union B are all the elements that are in both sets, that are in either A or B, and we combine them. But the complement in sets are elements that are not part of the set in question, but they are part of the universal set. They are part of the universal. They are outside the set in question, or the set we're concentrating on. In this case, let's follow me up here to what we have. We have identified our union as 1, 2, 3, 4, 5, 7, and 9. But we know that in the universal sets up here, we have 1, 2, 3, 4, 5, 7, and 9. So that means the complement of the set will be 6 and 8 that are out of the set in question. And if you can look at what we started with here, you see 6 and 8 are outside of the set. You see here, 6 and 8 are outside of the set. 6 and 8 outside of the set. So that's how. So the complement of the set, you see where we have shaded outside of the set. So any member part of the universal set, but not part of the sets in question, will make up the complement of the set. So this is what we have as the complement of the set. Now the next thing I need to show you is how we calculate sets, set operations using mathematical values. Now look up here. If you look at what we have, you have number of the union. I've written as 9. How did I get 9? 9 is from here. We have 9 members. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So number of union is 9. Number of A is 5. 5 is from here. 1, 2, 4, 5. So 1, 2, 3, 4, 5. You're 5. Number of B is 4. 1, 2, 3, 4. That's how we got that. 4. So that's how we have that. Now in real life, we may not be able to list all the members of a set. We're not able to count them, list them, but we now represent them by number. We represent them by number so that we can do some operations on them. So let's look at the board again. We have this. So the number of A intersection B is 2. Now, this is a general formula for determining the union of two sets. It is giving us number of A plus number of B minus number of A intersection B. I want you to take note of that formula. We have number of A plus number of B minus number of A intersection B. Now, let's now put these values in here. We know that number of A is 5, as you see here. Number of B is 4, and we have minus number of A intersection B, and that's minus 2. We have 2. Number of A intersection B is 4 and 5. So 5 plus 4, that's 9, minus 7 will give us what? Minus 2 will give us 7. 9 minus 2 will give us 7. Now let's go and count what we have as the number of A union B. Look at what we have here. Look at A union B. Let's count the number of elements of 1, 2, 3, 4, 5, 6, 7. So you see that we're correct. We're correct in finding the number of A union B. Let's look at how we can solve another one. We have A minus B, which is A only. And the formula is number of A minus number of A intersection B. Number of A minus number of A intersection B. We know that number of A is 5, and the number of A intersection B is 2. So 5 minus 2 will give us 3. Let's go and count what we have as the number of A only. What do we have as number of A only? Look up here. How many? 1, 2, 3. So that we're correct in looking at the number of A only or A only. Now B only 2 will also be number of B minus number of A intersection B. So number of B is 4 minus 2, which is intersection. 4 minus 2 gives us 2. And here on the board, you see number of B minus A is giving us 2. That's 3 and 9. So we have 2 elements there. Now, some people may be asking, why are we having this formula like this? Now, let me illustrate from here. Follow my hand as I look at these things. Now, if I draw a circle around A, look at A. I draw a circle around A like this. I'm counting. I've gone once, and then I go like this again. I've gone once. But you will take note that at this point, or at this middle of my movement, I have gone twice. I've gone around here once, and I've gone here again twice. But around these places, I only went once. Around this place, I only went once. So in order to give a balance so that members are not counted twice, that is why we deduct the value of the intersection so that we will not have to count twice. Do you understand? Look at my illustration again. I have my hands going around. I'm looking at all the members. I've gone around like this. Then here B, I'm going like this. Do you see it? Now, around this area, I've gone twice. I've gone this way, I've gone this way. But for here, only once. For here, only once. So in order to count, every member should be counted just once. That's why we have to reduce this one by 1. We have to reduce it. So that's why we have a number of A intersection B. All right, let's look at the next one. We have A union B complement. A union B complement. And A union B complement will be number of the universal set minus number of A union B. So the members that are outside of A union B. We know that A union B, what did we get? 7. This is it. A union B, the answer is 7. So, and the number of universal set, remember 1 to 9, then 9 members minus 7, that gives us 2. So 2, where are these 2? 2 are 6 and 8. So we have 1, 2. So we have 2 members in this as part of the complement of A and B. I trust with this short video that I have put together, you can appreciate set theory, notations, and illustration, as well as operations of sets. In upcoming videos, we are going to do more examples so as to establish your understanding of sets, looking at how to count, how to solve problems in sets. Thank you very much.